Hi guys, I thought I would make a video for the last three examples from the presentation that we didn't get to. So if we look at this one, it's kind of hard to see what u should be, but u should be the like inside function here. So you can kind of see, I hope that you can see that it's the cosine of 2 theta. So then the du d theta here, not du dx just because our variable is theta, would be the derivative of this. So the derivative of cosine of something is negative sine of something times the derivative of the something. So you get another 2 out of that. So let's solve this for d theta. So that would end up being du over negative 2 sine of 2 theta. So if we try to go back and plug this in here, so I'm going to have the sine of 2 theta here still from up there. And now this denominator would be u cubed. And then the d theta is du over negative 2 sine of 2 theta. So you can see that these two expressions cancel, and then you have no more theta, so that's good. So I'm going to bring this negative 2 to the front as a negative 1/2. And I'm going to rewrite this u cubed as u to the negative 1/3. All right, so now let's find the new bounds. So if theta is 0, let's plug that into here and see what we will get. So the cosine of 0 is 1. So this new bound will be 1. And now let's plug in the pi over 6. So here I have the cosine of 2 times pi over 6, which is the cosine of pi over 3, and that's 1/2. Yes, you have to know how to do that without a calculator. All right, so now let's go ahead and let's take the antiderivative. So I'm going to add 1 to the power, so now that'll be negative 2. And I want to divide by the new power. So dividing by negative 2 will be a negative 1/2 times this negative 1/2 would be positive 1/4. And now we're going to put this 1 and this 1/2 here. So if you wanted to go back to x, you could, and I'll show you that in a little bit too. So let's plug this 1/2 in, the 1 in, and then subtract. So I get 1/4 times 1/2 to the negative 2 minus 1/4 times 1 to the negative 2. So 1/2 to the negative 2. So the negative flips it, so then it becomes 2 to the 2, which is 4. 4 times the 1/4 is 1, minus, and then 1 to the negative 2, that'll still be 1, times the 4th will be a 4th. So this is 3/4. So I'm just going to kind of show you an alternate way of doing this here. So let's say I didn't want to change my bounds. That's fine. This still would have been written as negative 1/2, the integral of u to the negative 3 du. And I wouldn't write bounds there. I'm just not going to worry about the new bounds. I'm just going to go back to x. So now you'd add 1 to the power. So it'd be u to the negative 2 divided by the new power. That's still going to be 1/4. And then now I'm going to go back to x. So it will be 1/4 times, or theta, cosine of 2 theta to the negative 2. And that's where I'm going to go from 0 to pi over 6. So now I'm going to plug the pi over 6 in, so I get 1/4 the cosine of 2 times pi over 6, which is pi over 3, and that's all going to be to the negative 2 power, minus 1/4 the cosine of 2 times 0, all to the negative 2 power. So now you have to think, all right, what's cosine of pi over 3? And you should know that that's 1/2. So then I get 1/4 times 1/2 to the negative 2 minus 1/4, and then cosine of 0 is 1 to the negative 2. And then from there you can evaluate it. You can kind of see that it's the same as this example there. So it still ends up being 3/4. So either of these methods are fine. The AP test sometimes writes multiple choice questions that force you to do it the purple way. And I think it's a little bit easier the purple way, so I would encourage you to do it like that. All right, 2 more examples. So here, let's look at u. So u should be the inside function. I think it's easier here to tell that it's going to be 1 plus x cubed. Now let's find du dx. So that's going to be 3x squared. And if we solve this for du, we get dx over 3x squared. You can kind of see that it's going to work out nicely. All right, so now let's do we're going to take the integral of, I'm going to write the 3x squared here, but if you can just see that it's going to cancel anyway, then you don't have to write it. And then this becomes the square root of u, and then dx equals, oh, I did that wrong. Sorry. I had them flipped. So dx equals du over 3x squared. So this is du over 3x squared, and they cancel. So now let's find our new bounds. So if I plug 0 into this, 1 plus 0 cubed is 0. Or I'm sorry, is 1. Then if I plug 2 into that, you get 9. So now I'm just going to rewrite this because it looks a little crazy. And this square root of u is really u to the 1/2. So now let's do the antiderivative. So we're going to add 1 to the power, so that's 3 over 2, and then multiply by the new power, or divide by the new power, so that's 2/3, from 1 to 9. So now let's plug in our top bound, so it's 2/3 times 9 to the 3 over 2, minus 2/3 times 1 to the 3 over 2. So now 9 to the 3 over 2, well, that over 2 will square root the 9 to the third power will make it 27. So 27 times 2/3 is 18. Minus, and then 1 to any power will still be 1, so minus 2/3. So this is 17.333. If you want to write it as a fraction, that's fine too. Alright, so now let's look at this one. So here, if you kind of think about what the u should be, I know it might not be obvious, but it should be this denominator here. 1 plus 5x squared. So then du dx is 10x. So now let's solve this for dx, and you get du over 10x. So now let's do the rewriting. So I'm going to have the integral. I'm going to leave this x in the numerator for now. That's all going to be over u. And then dx is going to become du over 10x. And you can see that the x's will cancel here. So I'm going to bring this 1 over 10 to the front. And I'm going to write this as 1 over u du. I know that normally when I have something in the denominator, I rewrite it like with a negative power. But this is going to be that special case where it's u to the -1. So adding 1 and getting 0 and dividing by 0 isn't going to work. So this is a natural log example. So I'm going to get 1/10 the natural log. Oh, I forgot to do my bounds of u. But let's go back and do the bounds. I'm sorry, I forgot to do that. So if I find the new bounds, I'm going to plug 0 into this, and you're going to get 1. And if you plug 1 into this, you're going to get 6. So now we're going to integrate this from 1 to 6. So I get 1/10 the ln of 6. And you can just leave like that. You don't need the absolute values anymore because the absolute value of 6 is just 6. Minus 1/10 the ln of 1. The ln of 1 is 0. So this just becomes the ln of 6 with a 1/10 in the front. Okay, I hope that helps. Please message me if you have questions. I know that this can be, this can be really confusing. All right, thanks guys.